Welcome to Zmanda, the leader in open source backup. This is a demonstration of Zmanda Recovery Manager for MySQL Cluster Edition. ZRM for MySQL Cluster Edition allows for a consolidated and centralized backup of MySQL databases with minimal application and user impact. It supports clustered and non-clustered storage engines, as well as a granular recovery point objective. In a typical environment where you have a MySQL cluster, as well as MySQL servers, you can back it all up using ZRM. ZRM gives you the flexibility to schedule full and incremental backups. It is built with a plug-in architecture. This allows you to customize options such as compression, encryption, and pre- and post-backup plugins to best suit your environment. ZRM allows you to monitor and report about backups by either email or RSS feeds, as well as providing the option for backup compression and encryption. Backup sets can be configured for the enforcement of site or application-specific backup policies. For our demonstration, we will be using the configuration illustrated in this diagram. Our ZRM backup server, Quartz, is running a Red Hat Enterprise Linux 4 server and is configured with MySQL 5.1 Client End Server and ZRM for MySQL Cluster Edition 1.2. Quartz has been configured as our NDB Cluster Management Server and MySQL application node. Our cluster has 2 data nodes configured. Both data nodes are configured with the ZRM for MySQL Socket Copy plugin, as well as the MySQL 5.1 cluster storage engine. We will demonstrate configuring a full backup, followed by a use case recovery scenario of the movies database. Let's start by configuring Quartz to back up our MySQL cluster. First, we will create a backup set called Daily Backup and copy the default MySQL-ZRM configuration file into the Daily Backup directory. Next, we will edit the MySQL-ZRM configuration file in the backup set directory we just created and make the following changes. We will turn on compression. By default, ZRM uses gzip to compress the backup. You can use gzip or specify your own compression utility. Next, we will turn on encryption. We will also have to specify the path to the encryption plugin, which is installed as part of the ZRM installation. Most importantly, we must specify the path to the Socket Copy plugin, as well as the host name of our NDB management server, which in this case is Quartz. Since we will be using GPG encryption, we must create the passphrase file on the ZRM backup server. We will now execute a full backup of the backup set Daily Backup using the following command: mysql-zrm-scheduler. As you can see, ZRM displays the backup date as well as the backup directory where ZRM will back up the database. Also displayed is a list of data nodes being backed up. ZRM allows the user to verify the integrity of the backup images using backup checksums for each backup set. It is best practice to verify the backup images for all backup sets on a regular basis. Let's take a look at our backup reports. The first report shows some performance metrics, such as the time and date of the backup, the size of the backup before and after compression, as well as the total backup time. The second report shows the application performance metrics, such as the total read lock time. Please note that only read locks are issued during the backup windows. We will now demonstrate how to recover from a user error. A user who was trying to update the movie ID table within the movies database accidentally dropped the movie ID table. We will first recover from the last full backup and verify the database was recovered successfully, along with the movie ID table. We must then make sure that the MySQL cluster has been started and both the data nodes are connected. Next, we will verify an empty movies database exists on the MySQL node. We will now perform a restore of the movies database. Using ZRM's reporting capability, we will identify the last full backup. We'll use the mysql-zrm-restore command to restore the full backup. Be sure to specify the correct location of the backup. Upon further verification, we can see that we have successfully restored the movies database to the state that it was in at the time of the last full backup. This demonstration shows how ZRM tackles the challenges of backup and restore of a MySQL cluster. ZRM provides the ability to perform consolidated backups from all data nodes. It is the one common backup and recovery solution for all of your MySQL storage engines. It catalogs and organizes backups according to backup date. As we saw in the demonstration, enterprise features available for MySQL cluster backup include monitoring, reporting, compressing, and encrypting of backups, as well as the ability to schedule backups. More information for ZRM for MySQL is available by registering with the Zmanda network free of charge. This gains access to white papers, knowledge base, support portal, and tutorials and webinars. Tested and certified software is available by subscription. For more information about purchasing ZRM Cluster Edition, contact sales@zmanda.com or call us at 1-888-4-ZMANDA.